Vanessa's with us now. Okay. All right. So I'm only missing Josh. So, okay. So we're going to talk about factors and prime factorization. So we're going to be on page 174 on page 174. Okay. Okay. So there's a yearbook example there. You're working on your school yearbook. Each page will have 24 students' photos. Okay, so the photos will be arranged in a rectangular display with the same number of photos in each row. How many ways can you arrange the photos so that there are no more than 10 photos in any row or column? Okay, so you have rows and columns, right? And you want to put in 24 of them, right? So which ways can you do it? You can do 6 by 4, right? You can have 6 and 4, right? Or you can have 2 by 12, okay? 3 by 8. Obviously 1 times 24, 1 by 24, right? That's not much of a rectangle. That's more of just a huge line, right? Whether it's a 1 row or whether it's just 1 column, right? Okay. So these are your really, well, actually you can go backwards, right? You can go 4 by 6, you can go 12 by 2, 8 by 3, 24 by 1 also, right? 1, 2, 3, 4, 5, 6, 7, 8 different type of combinations that you can use here. But there's another constraint here, right? It says there are no more than 10 photos in any row or column. So we cannot do something that is greater than 10, right? Because it's no more than 10. So which one goes away? This goes away because I have 24 by 1 and 1 by 24. And then this one goes away because I have 12, right? 12 by 2 or 2 by 12. Neither one of them works. So actually you're going to end up with 1, 2, 3, 4 different ways, right? 4 different ways, okay? So this is the factorization of it. This is what we call factoring, okay? All right, so that was example 1, actually. If you go to top of page 175, there's a little paragraph there that says a prime number is a number that is greater than 1 and it has exactly 2 whole number factors, 1 and itself. In other words, is divisible by itself and only 1. Okay, all right. So let's see what kind of numbers are prime numbers. All the other numbers are called composite numbers, by the way. All the other numbers are called composite numbers. So 1, 2, 3 is 4 a prime number. Can anybody tell me if 4 is a prime number or not?
No.
No.
Why not?
Because 2 times 2 equals 4.
Correct. There you go. Great. So next one will be 5, not 6. So really, any even number is no good, correct? Because it's divisible by not only by itself, but it's divisible by 2. So all the even numbers are out, really, except for 2, right? 7, 9 is no good because 9 can be 3 by 3, right? 11, 13, not 15 because 15 is 3, but 3 times 5. Then we have 17, and we have 19. What about 21? 21 is good? Is that a prime number?
No. 3 times 7.
3 times 7, good, exactly. What about 23? That's a prime number, right? Because it's only divisible by 1 or 23. 25 is no good. 5 times 5. 27 is no good. 29, right? 31, not 33, not 35. 37, not 39, because it's 3 times 13. And you can go on and on and on, right? So you get the kind of the gist of what's going on here, right? Okay. There are actually, believe it or not, there are mathematicians who make a living doing nothing more than finding prime numbers, okay? All right, interesting fact. All right? People win Nobel Prizes off of finding the next prime number. Okay, anyway, so this is how we go, okay? So this is what a prime number is. So prime numbers are a number, again, a prime number is a number that is divisible by 1 and itself, and not divisible by anything else, okay? Let's look at example number 2. So here's something very important, so let's keep a close eye on this. Example number 2. Write the prime factorization of 630. So we're going to do a factorization. In other words, we're going to try to represent 630 by the multiplication of nothing more than all prime numbers. You can only use prime numbers here, okay? So this is divisible by what? 63 and 10, right? So 63 times 10 is 630, right? 10 is what? 2 times 5, correct?
Yes.
And then 63 is 7 times 9. Are these all prime numbers here?
No.
Why not?
9 is 3 times 9 is 3.
Yeah, 9 is 3 times 3, right? 3 times 3, and the 7 just comes down, 2 comes down, and 5 comes down. So now I have 1, 2, 3, 4, 5 different, these are all prime numbers, correct? So I can say that 630 is 3 times 3 times 7 times 2 times 5. Or I could say 3 squared times 7 times 2 times 5. Okay, this is what we call the prime factorization of a number.
Mr. On,
Yes.
does it matter what order you put the factors
No,
in?
it does not. It does not.
Okay.
Traditionally, or most people are going to go from the smallest number times 3 times 5 times 7. It doesn't really matter, okay? Well, you do not have to put them in any order here, okay? So that's 630, okay? Let's try you could have done it a different way, right? You could have approached this as not necessarily 630 by 10. You could have said this is what? 30 times 21. And then you could have went, well, this is 3 times 7. This guy is 3 times 10. Well, I have still one more here, right? This is 2 and 5. So I have 2, 5, 3, 7, 3. So this again is 2 times 5 times 3 times 7 times 3. I have the 2 3s, just like I had the 2 3s here. So it doesn't really matter how I approach it in the end, as long as I have nothing more than prime numbers here at the end, I'm good to go. Okay, all right. So let's see if we can do one more of these. Just so I want to make sure that you guys are pretty set on this. Let's see if we can do 240. 240, okay. So 240 is what times what? Logan, give me a branch. What two numbers can I multiply to get 240? Logan?
I'm thinking. I'm thinking.
Okay, take your time.
$120.
120 times 2, right? 2
Yeah.
times 120, correct? Correct. So now I can, since this is a prime number already, so I'm good to go with this one. Now I have to branch down 120. What do I get from, how do I get 120?
62. I mean 60, then 2.
60 times 2, okay.
Yeah,
good.
60 times 2.
Okay, now this is a prime number. This is good to go. What about 60?
Then 30.
30
Times 2.
times 2. Now this is another prime number. I'm good with this one. What about 30?
15 times 2.
15 times 2, good. And then 15? is 3 times 5.
Oh yeah, 3 times.
So there we go. Now I have 3 times 5 times 2 times 2 times 2 times 2. So this is going to be equal to 3, 5, 1, 2, 3, 4. 1, 2, 3, 4. There you go. Okay? Good job. Well done. Okay, so that's how you do that. All right? Okay, so let's move on. That was example number 2. Let's go to flip the page, go to page 176. On page 176, we have factoring monomials. Okay, monomial. A monomial is a number, a variable, or the product of a number and one or more variables raised to whole power numbers. Okay, so you can see the examples there of monomials. Okay, so if I have a monomial there, so let's go ahead and see what we do with this. Okay, so you can see that monomials are just one term. They're just one something that's all multiplied together. There is no plus, minus, or anything like that. Okay, let's go to example number 3. Example number C, factor the monomial 28xy cubed. Okay, so in this situation, you have a number times a bunch of variables, right? So let's look at the number itself, okay, the number itself, 28. So how does 28 factor out? 28 is factored to, obviously, 4 times 7, right? Or this is not a prime number, so I have to factor this one more time, 2 times 2. So 28, the 28 part is 2 times 2 times 7, 2 times 2 times 7. Then I have the x and the y cubed. So it's going to be x, and I only have one x, but I have 3 y's. Y, y, y. You see how that was done? Okay, so the y cubed is basically separated to y times y times y, which is what y cubed is, right? We already talked about that. Then 28 is 2 times 2 times 7. You just multiply them all together. Okay, so this is how you would do the factorization or prime factorization of a monomial. Monomial meaning you have the variables here, and you have just a number over on this side. Okay? All right. So we're done with that.